So let's talk about Mantra's rendering settings, although again, keep in mind that most renders have similar settings on them. They just work differently under the hood, and maybe they present it to you differently on the top of the hood, I guess. But a lot of the principles are similar. And again, Mantra is still alive and kicking regardless. So first things first. Click over to the Mantra node. Talking about rendering, so click the rendering tab. We can turn allow motion blur on later, but again, it will slow things down considerably. And I don't even know that we necessarily need it for this lesson because things aren't moving that fast. But there it is. I guess we might as well talk about it. I'll pause this. To get to see motion blur, make sure the node that's being rendered, in this case render smoke, on its sampling tab has on velocity blur. Velocity blur means if your regular polygonal geometry, look for the V and W. W is angular velocity. Look for those attributes to determine the velocity. If you are a volume, look for the vel volume. The vel volume is there. There it is, X, Y, and Z. It came from the sim. So if I turn on allow motion blur, it has to think about it because it needs to redo the whole thing. It needs to actually store that in the renderable thing. So does it look different? I mean, it does. You can see how it's moved a little bit. It got dragged forward a little bit. Is it different? It's not in our case because we don't have strong velocities. Even when we were sourcing the velocity into our scene here, remember we scaled it down by like 0.1 or, scaled it down 90%. So, I'm just going to turn it off. It's not really worth it in this case. But there it is. I mean, many times you will need it, so you should absolutely know about it. Now, the main event, actually, we might as well start with it, and they have it up front and center here, is the pixel samples. Every single one of these pixels, we can look at them. Press I to bring up the inspector here. You can right-click and drag to zoom in if you want, but even if you don't zoom in, the inspector is doing that for us. Obviously, an image is many pixels, but every pixel has a final color determined by something. The ray is passing out from the camera through the image pixel, and then it continues into the scene to find out what color should I be? What color should I be when I grow up? So it sets off into the world to go find out what its destiny color is supposed to be. Now, in fact, what happens is that pixel doesn't just send out one ray. It doesn't just continue as one ray. What happens is this many rays comes out of it. In this case, it says 3 by 3. So it's a 3 by 3 grid. So that one pixel is really subdivided into 9 squares. And each of those are the rays that go out into the world. And then that final, whatever their 9 destinies are averaged together to be the final color. So here's a fun little example, really with just 2 by 2 pixel samples, also known as 4 pixel samples, where we have a camera, we have a pig head, not technically a volume, but just as an easier idea to wrap your head around. And then this is the image that's actually being rendered. And so the way a render happens is there's rays being cast out from the camera, and if they pass through the pixel, and if they intersect something, the pixels record that. So we end up with is an image. So, but you didn't know, you can make a ray tracer in SOPs pretty easily. So what does that mean? Well, I want to show you specifically how one pixel is made up of these 4 pixel samples, because I'm saying in this case 2 by 2. So mostly blue and 1 red averages out to mostly blue, but with some red, which is purple. So you can see here's just 1 blue and, well, 2 blues apparently, and 2 nothings make a very light blue. And that's what's happening. The nothings are when the ray is missing the pig head entirely. The blues are when the ray is actually hitting the blue from the camera through the image, through the sub-pixel sample, and then it's averaged. And that happens for every single pixel. And that's the thing. So if every pixel needs 4 of these samples, then it takes 4 times as long to render this image because, you know, the ray hits the pig, but then it has to figure out what the lighting is. It has to send rays at the lights, as we'll see later, and do other stuff. So yes, I think you get that. Hopefully that it has to do 4 times as much work, and that's why we need to be careful with pixel samples. Isn't that cool? Yeah, let's just take that in for a minute. It's been a long time making this demo. I want to enjoy it. Yeah, cool. All right, anyway, so there it is, your pig head rendered to a piece of geometry. Pixel samples. In practice, what that means is that if you put 1 by 1, it's going to render crazy fast. It's also going to look like garbage. So it looks very grainy. Super, super grainy. So if I were to, you know, compare it to what it just was, you can see how grainy it was and how thing it is now. You can also see that this rendered in 2 seconds, and that rendered in 17 seconds. So obviously, asking it to do 9 times as much work, obviously makes it take longer. So 9 times the 2 seconds is 18 seconds, which is approximately what we got here. So it's 18 times as much work. And the same goes for if you were to raise it. If we went to 6 to 6, it's going to take way longer because now it needs to do 36 times as much work, at least versus the 1 pixel sample. So as usual, hey, make this as high as you can. It'll always look better. That said, it gets exponentially worse. So it slows down very fast once you get past the default, which is 3 by 3. I often find that I do not need to go any higher than 3 by 3. So don't if you can get away with it. There's other settings that will increase the quality of your image without you having to do that. Because, and this is the ultimate thing to know about pixel samples, because it's saying subdivide the pixel into 9 pixels and then shade each one and average it, that means everything else that it's doing, the entire render is being multiplied that many times. Whereas other quality settings down here do not require nearly as much work to be done. If you were, put another way, if I were to increase, let's say, the quality of a thing down here, it's increasing the quality in all 9 samples or in all 36 samples. So anything you do here is being multiplied by this. So don't start with this because it's multiplying the quality of everything. In practice, there's really only 1 or 2 of these things that we need to increase, as opposed to increasing the quality, increasing the work that every single one of these things needs to do. I hope that makes sense. If each one of these things takes a certain amount of work, right, and we only increase the amount of work that one of them has to do, well, then that's only that much more work. But if we say increase everything at once, we might be increasing things that are not actually adding any appreciable improvement to the image. So we want to target where we are spending extra work. I think that's maybe a better way of putting it.